This video will be expanding on colinearity, intersection, union, congruence, and all such things in regards to angles and lines and line segments. We're going to go through these one at a time. I will be writing in red just to set it off. First, name all points that are collinear with G and I. G, I. Points that are collinear with G and I are B and D right here. B, D. In geometry, if an angle looks like a straight angle, angle BGD, it is a straight angle, and we can assume all points along that line or line segment are collinear. Next, are CH and D collinear right here? CHD. C, H, and D. Again, if 3 points appear to be collinear, yes, they are. Also, you could think of this as angle CHD is a straight angle. It is 180 degrees. These are all collinear, and H is between C and D. Next, which segments do the tick marks indicate are congruent? Well, we've got this thing right here, the circle and the circle. So segment ED and segment BC can assume to be congruent. Next, is angle ABE congruent to angle FED? So angle ABE, which is a right angle, and angle FED, which is also a right angle, you can tell by the squares right there. So, yes. And the reason is they are both right angles. That is the symbol to show right angles. For proof, you would say if angles are right angles, then they are congruent. Next, is angle EGI, angle EGI, coming from there, congruent to angle BGC, BGC? Again, the answer is yes, because they are vertical angles. Vertical angles. If two angles are vertical angles, then they are congruent. Next, where do line GI and line CH intersect? It's important that this is a line and this is a line, as you'll see in a minute. So a line goes through those 2 points, goes on forever and ever. And line CH goes between those 2 points, goes on forever and ever. And the intersection is here at point D. Now, let me show this in green. If it was line segment GI, it would just be from here to here. And line segment CH would be from there to there. And line segment CH would be from here to here. Those would not intersect. So if that were the case, it would be empty set. But lines go on forever, so they intersect at point D. Next, what is the intersection of line segment GI and line segment ID? GI and ID. So GI is there, ID is there, and the intersection is point I right there. Now, what is the union of GI and ID? So it's the same two line segments, GI and ID. This time it's the union, so one or the other or both. So this would be line segment GD. Next, name all rays that could include point I. This is a much longer answer than I realized when I wrote it, because it's just any ray that passes through that point. So it could be ray ID, it could be ray IG, it could be ray IB. That's all rays starting with point I. It could be ray DI, which is different than ray ID because one starts at I and goes to D, one starts at D and goes through I. So DI, ray DG, ray DB, now starting in G, GI, ray GD. Now notice real quick, ray GB would not go through I. Then we have ray BD, ray BI, ray BG, and that should do it. So as you can see, again, rays start at a point, say G, and go a certain direction. So any ray that starts along here and goes through I will be included. Take a minute, write that down again. It'll be very, very good practice. Next, name all points between B and D. So here we have B and D. As stated before, you can assume that BGD is a straight angle. You can assume this whole thing is a straight line segment. Therefore, point G and point I are both between B and G because they lie on the line segment and they are between B and D. Now I'm going to go to orange because this is a separate figure and a separate problem. Can you assume that any of angles J, K, L, or M, J, K, L, or M are right angles? And the answer is no. Yes, they appear to be right angles. However, what if this one is 90.00001 degrees and this one over here is 89.997 degrees? In geometry, to assume a right angle, you have to be told. There has to be one of these, or in the givens for the problem, they will say this angle is a right angle. Thank you for watching. I hope this video is helpful in your geometry. As always, the best thing you can do for yourself is stop the video and do the problem again on your own. You won't fall behind if you put in the practice.